Today we are going to start next exercise, which is exercise number 1.3. It is totally depend on logarithmic differentiation and derivative of implicit function. Here first question is, differentiate the following function with respect to x. Example number 1 is x plus 1 whole bracket square upon x plus 2 whole bracket cube upon x plus 3 whole raised to the power 4. So the given function is in the form of complications. It means that first it is a question from in denominator two terms are in multiple forms and the terms power is given. Hence this type of question we solve by using logarithmic functions or logarithm. First we consider the whole function y is equals to x plus 1 whole bracket square upon x plus 2 bracket cube upon x plus 3 whole raised to the power 4. Now we take log both sides. If we take log both sides, then we can write log of y is equals to log of x plus 1 bracket square upon x plus 2 bracket cube into x plus 3 whole raised to the power 4. Now by using the rules of log of m upon n, we can write it log m minus log n. Similarly, we can apply here the rules of log of m upon n. We can write log of x plus 1 bracket square minus log of x plus 2 bracket cube into x plus 3 whole raised to the power 4. Next, here two terms are in multiple conditions. In logarithmic conditions, if m and n are two terms, then we can apply here log of m into n, which is log m plus log n. Hence we can write it log of x plus 1 bracket square minus log of x plus 2 bracket cube plus log of x plus 3 whole raised to the power 4. Again we know about the rules of logarithm, which is log of m raised to the power n. We can write it n log of m. Hence by applying this rule we can write 2 log of x plus 1 minus 3 log of x plus 2. This plus minus minus, if we take this 4 before the log, we can write 4 log of x plus 3, which is function log of y. If now we differentiate the given function with respect to x, then we can find dy by dx. Now differentiate with respect to x. The derivative of log y, which is 1 by y, dy by upon dx. 2 is constant and the derivative of log of x plus 1, 1 upon 2 upon x, 1 upon x plus 1. Again we can take a derivative of x plus 1. Derivative of x is 0. Sorry, derivative of x is 1 and derivative of 1 is 0. Minus 3 upon derivative of log of x plus 2 is x plus 2, 3 upon x plus 2. We can take again the derivative of x is 1 and derivative of 2 is 0. Again take minus 4 upon log of x plus 3 is x 4 upon x plus 3. We can take again derivative of x is 1 and 3 is 0. After that, if we shift this y right side, then we can write dy by dx is equals to y into 2 into 1 is 2 upon x plus 1 minus 3 into 1 is 3 upon x plus 2 minus 4 into 1 is 4 upon x plus 3. If we substitute the value of y in this equation, we can write it y, which is x plus 1 whole bracket square upon x plus 2 bracket cube into x plus 3 whole raised to the power 4 into 2 upon x plus 1 minus 3 upon x plus 2 minus 4 upon x plus 3, which is the required derivative of y dy upon dx. So again the question, example number 2 is cube root of 4x minus 1 upon 2x plus 3 into 5 minus 2x whole bracket square is in the complications form. This type of question we solve by using logarithm. First we consider whole function y is equals to cube root, which means 4x minus 1 upon 2x plus 3 into 5 minus 2x whole bracket square whole raised to the power 1 by 3. Now we take log both sides. If we take log both sides, then we can write this y log y. By using the rules of log of m raised to the power n is equals to n log m, we can write it 1 by 3 into log of 4x minus 1 upon 2x plus 3 into 5 minus 2x bracket square. Now here we can apply the rules of log of m upon n. We know that log of m upon n is log m minus log n. By applying this rule, we can write it 1 by 3 into log of 4x minus 1. This terms, my negative terms, minus log of 2x plus 3. Also we can write plus minus 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 log of 5 minus 2x whole bracket square. Here again we can apply, the rules of logarithm, which is log of 4x minus 1 as it is. If we take this term out of the bracket, we can write plus minus minus log of 2x plus 3. Here minus plus minus. If we write this 2 before the log, we can write 2 log of 5 minus 2x, which is log of y. If we differentiate given function with respect to x, then we can write the derivative of log y is 1 by y dy upon dx. 1 by 3 is a constant function, and we can write the log of 4x minus 1 is 1 upon 4x minus 1, and we can take again the derivative of 4x minus 1. Minus log of 2x plus 3 is 1 upon 2x plus 3, and we can take again a derivative of 2x plus 3. Minus 2 into log of 5 minus 2x is 1 upon, or we can write 2 upon 5 minus 2x, and we can take again a derivative of 5 minus 2x. After that, if we shift this y right side, then we can write dy upon dx is equals to y by 3 into derivative of 4x is 4 minus 1 is 0. 4 into 1 is 4 upon 4x minus 1 minus derivative of 2x is 2. 3 is 0. 2 plus 0 is 2. 2 into 1 is 2. 2 upon 2x plus 3 minus derivative of minus 2x is minus 2. Minus 2 into minus 2 plus 4. We can write it 4 upon 5 minus 2x. After that, if we take the value of y, which is under root 3, we can write it 1 by 3 cube root of 4x minus 1 upon 2x plus 3 5 minus 2x whole bracket square into 4 upon 4x minus 1 minus 2 upon 2x plus 3 plus 4 upon 5 minus 2x which is the required derivative of y, dy upon dx. Next one, again x square plus 3 raised to the power 3 by 2 into sine cube 2x into 2x raised to the power 2. Such a function, first we consider that y is equals to x square plus 3 whole raised to the power 3 by 2 into sine of 2x whole bracket cube into 2 raised to the power x square. If we take log both sides, we can write it log of y is equals to, here log of x square plus 3 raised to the power 3 by 2 plus log of sine 2x whole raised to the power 3 plus log of 2x square. Again we apply the rules of logarithm, which is log of m raised to the power n. Then we can write this function again, the 3 by 2 into log of x square plus 3 plus 3 into log of sine 2x plus again x square into log of 2, which is a required function log I. Now if we differentiate with respect to x, then we can write the derivative of log y is 1 upon y dy by dx. Here 3 by 2 is a constant function. Again we can write log of x square plus 1, which is 1 upon x square plus 3, and we can write the again a derivative of x square plus 3. Second term, which is here plus 3 is constant. We can write the derivative of log of sine 2x is 1 upon sine 2x, and we can take again a derivative of sine 2x. After that, here again we can write log 2 is constant function, and we can take a derivative of x square. Now if we take this log right side, then we can write dy upon dx is equals to 3 by 2 into y. Here derivative of x square is 2x, we can write 1 upon x square plus 3 into 2x plus derivative of 3 is 0. Plus 3 into 1 upon sine 2x, and the derivative of sine 2x is cos 2x, and we can write again a derivative of 2x. Plus here log of 2 is constant as it is, and derivative of x square is 2x. Now again we can solve. If we put the value of y, which is 3 by 2 into x square plus 3 raised to the power 3 by 2 into sine cube 2x into 2 raised to the power x bracket square into 2x into 1, which is 2x upon x square plus 3. Here 2a derivative of 2x is 2. 2 into 3 is 6 plus 6 upon, or 6 into cos upon sine is cot 2x plus 2x into log 2 as it is, which is a required derivative of y dy upon dx. Sorry, this 3 by 2, which is only multiple of this bracket. Here y into 3 by 2. Now if we substitute the value of y, we can write 3 by 2 here into 3 by 2. Here 2 is cancelled. We can write x square plus 3 whole raised to the power 3 by 2 into sine cube 2x into 2x square into 3 into x is 3x upon x square plus 3 plus 6 cot of 2x plus 2x log of 2, which is the required derivative of y dy upon dx. Next example number 4. which is in question number first is x square plus 2x plus 2 whole raised to the power 1 by 2 upon square root of x plus 3 bracket cube into cos of x whole raised to the power x. First we consider the given function y is equals to x square plus 2x plus 2 whole raised to the power 1 by 2 upon under root x plus 3 bracket cube into cos of x whole raised to the power x. If we take log both sides, taking log both sides, we can write this function log of y is equals to, by using the quotient root which is log of m minus n, we can write it log of x square plus 2x plus 2 whole raised to the power 1 by 2 and again minus log of root x plus 3 whole bracket cube into cos of x whole raised to the power x. Now we apply again the rules which is logarithm log of m into n. Here we can write it 1 by 2 log of x square plus 2x plus 2 minus log of square root of x plus 3 whole bracket cube plus log of cos of x whole raised to the power x. After that again we can write this 1 by 2 into log of x square plus 2x plus 2 plus minus minus 3 log of under root x plus 3 plus minus minus x into log of cos x, which is a required function log of y. If we differentiate this function with respect to x, then we can write the derivative of log y is 1 by y dy upon dx. Here 1 by 2 is constant function and we take a derivative of log of x square plus 2x plus 2 is 1 upon x square plus 2x plus 2 and we take again a derivative of x square plus 2x plus 2. After that minus 3 into, we can take again derivative of log of square root x is 1 upon under root x plus 3 and we take again a derivative of under root x plus 3. Here minus this term x into log x which is in the multiple form m into n form. If we apply here log of m into n or log of u into v, then we can write it x into derivative of log of cos x plus log of cos x into derivative of x which is 1. Now if we take this y right side, then we can write y upon 2 into derivative of x square is 2x, derivative of 2x is 2 plus derivative of constant function 2 is 0 upon x square plus 2x plus 2 as it is. Here again we can write, sorry, this y, this 1 by 2 is multiple of only this bracket minus 3 into 1 is 3 upon derivative under root of x plus 3 and the derivative of root x is 1 upon 2 root x and the derivative of plus 3 is 0, hence we can write 2 under root x minus this x into derivative of log of cos x is 1 upon cos x and we take again a derivative of cos x is minus sin x minus plus minus and log of cos x as it is derivative of x is 1. Now if we substitute the value of y which is x square plus 2x plus 2 x square plus 2x plus 2 whole raised to the power 1 by 2 upon root x plus 3 bracket cube into cos of x whole raised to the power x into, here if we take 2 common, these 2 and 2 are cancelled, we can write x plus 1 upon x square plus 2x plus 2. Now again minus 3 upon 2 under root x into under root x plus 3. Here minus minus plus x into sin x upon cos x is tan x minus log of x, which is a required derivative of the given function y dy upon dx. Here log of cos x. Next one, which is question number 5. X raised to the power 5 tan cube 4x upon sin square 3x. First we consider that y is equals to, let y is equals to x raised to the power 5 tan of 4x, we can write it whole bracket cube upon sin of 3x whole bracket square. If we take log both sides, taking log both sides, we can write equals to log of y into this term, we can write log of x raised to the power 5 tan of 4x whole bracket cube minus log of sin 3x whole bracket square. Again we can write it log of x raised to the power 5 plus log of tan of 4x whole bracket cube minus log of sin 3x whole bracket square. Now again we can write it log of m raised to the power n is 5 log x plus 3 log of tan of 4x minus 2 log of sin 3x, which is log of y. Now if we differentiate with respect to x, then we can write the derivative of log y, which is 1 upon y dy upon dx. Here phi is constant function and derivative of log x is 1 by x. We can write it 5 by x plus 3 into derivative of tan 4x. Log of tan 4x is 1 upon tan of 4x into again a derivative of tan of 4x minus 2 into derivative of log of sin 3x is 1 upon sin 3x into again we can take a derivative of sin 3x. Here if we take y right side, then we can write it dy upon dx is y into this 5 upon x as it is plus 3 into 1 is 3 upon tan of 4x and the derivative of tan 4x is sec square 4x minus 2 into derivative of sin 3x is cos of 3x upon sin 3x. We can take again a derivative of 3x by using the rule, chain rule. If we substitute the value of y, y is x raised to the power 5 tan cube 4x upon sin square 3x into 5 by x plus this tan 4x means cot 4x into sec square x. We can write it sec square x upon sin into sec square 4x, which is 3 upon sin 4x into cos of 4x minus derivative of 3x is 3 into 2 6 cos x upon sin x is cot of 3x. If we take adjust 2 here, then we can write 2 sin 4x into cos 4x is sin 8x. This function dy upon dx is equals to x raised to the power 5 tan cube 4x upon sin square 3x into 5 upon x as it is 3 into 2 6 6 into 4 24 1 upon sin 8x is cosec 8x minus 6 cot of 3x which is a required derivative of y, dy upon dx. Example number 6 is x raised to the power tan inverse x. And if we have to find the derivative of this function, which is dy by dx, then we first take log both sides. Taking log both sides. If we take log, then this y becomes log of y. This log of x raised to the power tan inverse x. We know that log of m raised to the power n, and we can write it tan inverse x into log of x. Now if we differentiate given function with respect to x, then we can write the derivative of log y is 1 upon y dy upon dx. Here we apply u into v rules, then we can write tan inverse x into derivative of log x plus log x into derivative of tan inverse x. If we shift this y right side, then we can write dy upon dx is equals to y into tan inverse x into derivative of log x is 1 by x plus log x into derivative of tan inverse x is 1 upon 1 plus x square. The value of y is x raised to the power tan inverse x. Here tan inverse x upon x, which is tan inverse x upon x or 1 by x tan inverse x, plus log x upon 1 plus x square, which is a required derivative dy upon dx. Next again similarly we can solve this example y is equals to sin inverse whole raised to the power x. By using the similar condition, first we take log both sides. The value of y, which is log y. Here we can write x log of sin x. If we differentiate a given function with respect to x, then we can write the y log y is 1 by y dy upon dx. Here if we apply the derivative, which is x into log of sin x, by using u into v rules, we can write it x into derivative of log of sin x plus log of sin x into derivative of x. If we shift this y right side, then we can write it dy upon dx is equals to y into x into 1 upon sin x into derivative of sin x, again the derivative of sin x, plus log of sin x as it is, and the derivative of x is 1. The value of y, which is sin x whole raised to the power x, x into 1, x into derivative of sin x, which is cos x upon sin x, plus log of sin x into 1 log of sin x. Hence we can write it sin of x raised to the power x into x cos x into sin x cot x plus log of sin x, which is a required derivative dy upon dx. So the next question, which is question number 2, is differentiate the following with respect to x. The given function is in the form of implicit functions, and function is x raised to the power e plus x raised to the power x plus e to the power x plus e raised to the power e. Here we have to differentiate following function with respect to x. The given function, first we consider given function y is equals to x raised to the power e plus x raised to the power x plus e to the power x plus e to the power e. If we differentiate with respect to x, then we get derivative of y, which is dy by dx. Here derivative of x raised to the power e is e into x raised to the power e minus 1 by using the rules of derivative, which is x raised to the power n. Here we can't find the derivative of x raised to the power x because these rules are not available. Hence we can write derivative of x raised to the power x as it is. Plus, we know that the derivative of e to the power x, which with respect to x, is e to the power x. E to the power e is a constant function, and we can write a derivative of e to the power e is 0, which is equation number 1. Here, now we have to find derivative of x raised to the power x. Now, first we consider u is equals to x raised to the power x. If we have to find the derivative of this function, then first we take a log both sides. If we take log both sides, then we can write log u is equals to log of x raised to the power x. This x we can write before log, we can write it x log of x, which is log u. If we differentiate with respect to x, then we can write derivative of log u is 1 by u du upon dx. Here x into, we can take a derivative of log x plus log x into derivative of x. We know that here du upon dx is equals to u into x into derivative of log x is 1 by x plus log x into derivative of x is 1. X is cancelled. Value of x is equals to u x raised to the power x, and we can write x raised to the power x into 1 plus log x, which is the required value of du upon dx, and the value of u also we put x raised to the power x. Therefore, derivative of x raised to the power x is x raised to the power x into 1 plus log x. If we put this value in equation 1, then we can write equation 1 become dy upon dx is equals to e into x raised to the power e minus 1 plus derivative of x raised to the power x is x raised to the power x into 1 plus log x plus e to the power x, which is the required derivative of y dy upon dx. Example number 2, which is in question number 2, is x raised to the power x raised to the power x plus e to the power x raised to the power x. First we consider that y is equals to x raised to the power x raised to the power x plus e to the power x raised to the power x. If we have to find the derivative of this function, first we differentiate with respect to x the derivative of y, which is dy by dx. First we consider first function u is equals to x raised to the power x raised to the power x, and second function v is equals to e to the power x raised to the power x. Then y become u plus v. If we differentiate a given function with respect to x, then we get derivative of y dy by dx, which is du by dx plus dv upon dx, equation number 1. We have to find here du by dx and dv by dx. We take u is equals to x raised to the power x raised to the power x. If we take log both sides, then we can write it log u is equals to log of x raised to the power x raised to the power x. Again we can write it x raised to the power x into log of x. Now if we differentiate a given function with respect to x, then we can write derivative of log u is 1 by u du upon dx. Here x raised to the power x into derivative of log x is 1 by x plus log of x into derivative of x raised to the power x, which we give equation number 2. Again we have to find derivative of x raised to the power x. We can consider it, let w is equals to x raised to the power x. If we take log both the sides, taking log both side, we can write it log of w is equals to x log x. After differentiating with respect to x, we get derivative of 1 upon w d of w upon dx is equals to x into derivative of log x is 1 by x plus log x into derivative of x is 1. Again we can write it w right side, then dw by dx is equals to w into x cancel 1 plus log of x. Hence we can write it x raised to the power x into 1 plus log x, which is the required value of dw by dx. If we put this value dw by dx, we can write it the value of w is x raised to the power x, hence the value of derivative of x raised to the power x is x raised to the power x into 1 plus log x. Therefore, equation 1 become if we shift this u right side, then we can get du upon dx is equals to u into x raised to the power x upon x plus log of x raised to the power x into 1 plus log x. Here the value of u is again x raised to the power x raised to the power x, then we can write x raised to the power x raised to the power x into, here the power of x is 1. If we take numerator, it become minus 1. Hence we can write it by using the rules of indices x raised to the power x minus 1 plus x raised to the power x into 1 plus log x, x raised to the power x into 1 plus log x into log of x. Now again we have to find the derivative of dv upon dx. Here now v is equals to e to the power x raised to the power x. If we take log both sides, we can write log of v is equals to x raised to the power x into log e. We know that log e, the value of log e is 1. If we differentiate given function with respect to x, then we can write 1 upon v dv upon dx is equals to log e is constant function. We can take a derivative of x raised to the power x. We know that the derivative of x raised to the power x is x raised to the power x into 1 plus log x. Hence we can write directly dv upon dx is equals to value of log e is 1 v into x raised to the power x into 1 plus log of x. We can write again value of v, which is e to the power x raised to the power x, e to the power x raised to the power x. V is equals to e to the power x raised to the power x into x raised to the power x into 1 plus log x. Therefore, equation 1 become dy upon dx is equals to x raised to the power x raised to the power x into x raised to the power x minus 1 plus x raised to the power x into 1 plus log x into log x, plus here v is e to the power x raised to the power x into x raised to the power x into 1 plus log x, which is a required derivative dy upon dx. Next one, which is y is equals to log of x raised to the power x minus cos of x raised to the power cot x. First we consider again first function log of x raised to the power x is u is equals to log of x whole raised to the power x, and v is equals to cos of x whole raised to the power cot of x. If we take log both sides, then we can write it log of u is equals to x into log of log x. If we take again log here, we can write v is equals to log of v is equals to cot of x into log of cos x. First we differentiate both function, differentiate with respect to x, both. We can write the derivative of log u is 1 upon u du upon dx. If we apply u into v rules, x into derivative of log x is 1 upon log x, and we take again derivative of log x, which is 1 by x, plus log x as it is, and the derivative of x is 1. If we shift this u right side, then we can write du upon dx is equals to u into x into 1 into 1, you see here x cancel, 1 upon log x plus log x. The value of u, again we can write log of x raised to the power x, we can write it log of x whole raised to the power x into 1 upon log x plus log x, which is the value of du upon dx. Now if we take the derivative of v again, we can write it 1 upon v dv upon dx. By using the rules of u into v, we can write cot x into derivative of log of cos x is 1 upon cos x, and we take again derivative of cos x, which is minus sin x, plus log of cos x as it is now. We get again derivative of cos x, which is minus cos x pure x. If we take this v right side, then we can write dv upon dx is equals to v into minus sin x upon cos x, which is tan x. We can write it minus cot x into tan x plus minus cos x pure x into log of cos x. Here cot x tan x is cancelled, or cot x into tan x is 1. We can write it, the value of v is cos of x raised to the power cot x. If we take my negative sign common both terms, we can write it 1 plus cos x square x into log of cos x, which is the value of dv upon dx. Equation number 2. Equation number 3. Now y is equals to this u plus v. If we differentiate with respect to x, 1 and 2, we can write dy upon dx is equals to du upon dx plus dv upon dx. The value of du by dx is log of x whole raised to the power x into 1 upon log x plus log x, plus dv upon dx is plus minus cos of x raised to the power cot x into 1 plus cos x pure x into log of cos x, which is a required derivative dy upon dx. Now again similarly we can solve this. First we consider that y is equals to x raised to the power e to the power x plus log of x raised to the power sin x. First let u is equals to x raised to the power e to the power x, and v is equals to log of x whole raised to the power sin x. If we put value of u and v, then y become u plus v. If we differentiate with respect to x, then we can write dy upon dx is equals to du by dx plus dv upon dx. Equation number first. Now we take u become, now u is equals to x raised to the power e to the power x. If we take log both sides, taking log both sides, we can write it log u is equals to e to the power x into log x. If we differentiate with respect to x, then we can write the derivative of log u is 1 by u du upon dx plus e to the is equals to e to the power x into derivative of log x plus log x into derivative of e to the power x. Here if we take u right side, then we can write u into e to the power x into derivative of log x is 1 by x plus derivative of e to the power x is e to the power x into log x. If we take e to the power x common both terms, we can write the value of e to the power x u is equals to x raised to the power e to the power x into e to the power x common from terms 1 by x plus log x, which is the value of du by dx. Now we take v is equals to the value of v is log of x whole raised to the power sin x. If we take log both side, we can write log of v is equals to sin x into log x. And if we differentiate given function with respect to x, then we can write derivative of log v is 1 by v dv upon dx is equals to, here we have to apply u into v rules, sin x into derivative of log x plus, here again we can write log x into derivative of sin x. Therefore dv upon dx, if we take this right side, then we can write sin x into derivative of log x is log 1 upon log x. We can take again a derivative of log x plus log x as it is, and we know that the derivative of sin x is cos x. Here the value of e, which is log of x whole raised to the power sin x, value of derivative of log x is 1 by x, we can write it sin x upon x log x plus cos x into log x, which is the value of dv upon dx, equation number 3. If we put 2 and 3 in equation 1, we can write dy by dx is equals to du upon dx, means the value of du upon dx is x into e to the power x into 1 by x plus log x plus dv upon dx is log of x whole raised to the power sin x into sin x upon x log x plus cos x into log x, which is a required derivative of y dy upon dx. Next example, y is equals to e raised to the power tan x plus log of x raised to the power tan x. First we consider that u is equals to log of x whole raised to the power tan x. If we take log both side, then we can say that log u is equals to tan of x into log x. Now if we differentiate given function with respect to x, then we can write 1 upon du into du by dx, here tan x into derivative of log x plus log x into derivative of tan x. If we shift this u both right side, then we can write du upon dx is u into tan x into derivative of log x is 1 upon log x, and we take again derivative of log x, which is 1 by x, plus derivative of tan x is sec square x. We can write it sec square x into log of log x. The value of u, which is log x whole raised to the power tan x, we can write log x whole raised to the power tan x into tan x upon x log x plus sec square x into log of log x, which is the du by dx. Now if we take y become y is equals to e raised to the power tan x plus this whole terms we consider u. Now if we differentiate with respect to x, dy upon dx is equals to derivative of e to the power tan x is e to the power tan x into again the derivative of tan x plus du upon dx. We know that the derivative of tan x is sec square x, hence we can write is sec square x into e to the power tan x plus derivative du upon dx is log of x whole raised to the power tan x into tan x upon x log x plus sec square x into log of log x, which is a required derivative of y dy upon dx. Similarly, we can solve y is equals to sin x raised to the power tan x plus cos of x raised to the power cot x. First, we consider that u is equals to sin of x raised to the power tan x and v is equals to cos of x whole raised to the power cot x. If we put this value, then y become u plus v. If we differentiate with respect to x, then we can get dy by dx is equals to du upon dx plus dv upon dx, equation number 1. If we first find du by dx and dv by dx, then we can substitute this value in equation 1. Therefore, u is equals to sin of x whole raised to the power tan of x, and again v is equals to cos of x whole raised to the power cot x. If we take log both side u and v, we can write it log of u is equals to tan x into log of sin x. Log of v is equals to cot x into log of cos x. Again we differentiate both u and v with respect to x, then we can write derivative of log u, which is 1 by u du by dx. Here we apply derivative of u into v, tan x into derivative of log of sin x, which is 1 upon sin x into again derivative of sin x is cos x plus. Now log of sin x as it is, and we take again the derivative of tan x, which is sec square x. Cos x upon sin x. If we shift this u right side, then we can write du by dx is equals to u into tan x into cos x upon sin x is cot x plus sec square x into log of sin x. Cot x means 1 upon tan x, or this cot x we can write directly 1 upon tan x. Here tan x cancel, or tan x into cot x also 1. We can write this u means sin x raised to the power of tan x into 1 plus sec square x into log of sin x, which is the value of du by dx, equation number 2. If we differentiate log v, dv 1 by v dv upon dx is equals to cot x into derivative of log of cos x is 1 upon cos x into again derivative of cos x is minus sin x plus log of cos x as it is into derivative of cot x is minus cos x square x. Here if we shift this v right side, then we can write v into cot x into minus of sin upon cos means tan. We can write this into tan x, minus sign here, plus minus cosec square x into log of cos x. If we write this, if we take minus sign common both, and the value of v cos of x raised to the power cot x, we can write it cot x tan x, value 1 or cancel, each 1 plus cosec square x into log of cos x. Equation number 2, which is dv upon dx. If we put 1 and 2 in equation 1, 2 and 3 in 1, then we become dy upon dx is equals to sin x raised to the power tan x into 1 plus sec square x log of sin x minus cos x raised to the power cot x into 1 plus cosec square x into log of cos x, which is the required derivative of y dy upon dx.